If you're looking for an episode explaining how to collect logs with the help of the OpenTelemetry collector, then this episode is for you. Welcome back to the Is It Observable YouTube channel. Today's episode is going to be part of the OpenTelemetry series, where we covered several episodes such as the introduction to OpenTelemetry, how to instrument your application, how to build custom metrics, and how to observe your Kubernetes cluster using the OpenTelemetry collector. Today's episode will be again pretty much focused on the OpenTelemetry collector, where we'll look at a couple of receivers and processors allowing us to collect, filter, and enrich our logs specifically in a Kubernetes environment. If you enjoyed today's content, don't forget to like and subscribe to the channel. So let's see what you are going to learn out of this episode. We'll start with an introduction related to logs and how we can collect those logs in our cluster. We will look at the specific receiver for logs in the OpenTelemetry collector. And since KubeCon North America, there's been an amazing announcement related to the collector and specifically OpenTelemetry transformation language. So we'll cover and explain how to use it. Then we will look at the useful processors for logs and the useful connectors for logs. Logs is the oldest observability signals. Everyone who has coded in their life has also been generating logs from their code. In our logs, we can find lots of interesting information, functional data generating from our code to keep track on business-related information. Technical information helping us to keep track on the duration of a request or methods. Errors, we usually utilize logs to keep track on our errors, our potential stack trace, exceptions, and so on. And of course, we can do more with logs. But with the adoptions of distributed tracing and the OpenTelemetry metrics, we can almost consider redefining the notion of logging. Currently, lots of logs lines produced are considered to be tracing. I mean, we're building the logs to answer one question: how long did this method or function took? Details on the runtime or any type of context. We should use tracing to track those transactions or sub-transactions in our systems. So we should replace the way we're building logs with distributed tracing. Because tracing at the end is a perfect tool to understand where we are spending time in our system. Then we have metrics. Well, a metric is here to keep track on a KPI or a given indicator that we've built. So in the logs, sometimes we are reporting duration or stock or orders, or that could be basically transformed as a metrics. So log at the end is a perfect tool to keep track on events going through our systems. For example, if we have an error in our systems or if we have an exceptions, it will be perfect to track it in a log. And in the case of a web server, if we have a request coming in, it's an event at the end, we could basically use this information, and at the end we have an access logs. Currently, most of the language has an OpenTelemetry log SDK implemented, but the status is varying between stable and experimental, or sometimes even development. So here is the status of the current state of the log support for the various language. Of all the signals, logs has the biggest legacy. Most languages have built-in logging capabilities or well-known, widely used logging library. So the OpenTelemetry community decided to collect application logs in two distinct ways. The first way is utilizing the collector to read a traditional log file. The other way is using the log bridge that will intercept the log produced with our preferred logging library. If you're looking to attach your logs the OpenTelemetry context, so the trace ID, the span ID, the trace flags, then it will be recommended to use the logging library having a log bridge implemented. So what does it mean? When using the log bridge, the OpenTelemetry SDK will get our log line produced with our preferred log library, for example, log4j. And it will export it using the OTLP log protocol. The bridge will get the OpenTelemetry context, so if there is an existing log OpenTelemetry context, and it will attach it to the log record before exporting it to the OpenTelemetry exporter. At the end, OpenTelemetry logs rely on few objects. These details would only be useful when you will have to configure the log exporter through environment variables. But you should not initialize those objects within your code. At the end, we'll use the log bridge API. We have the log provider in one end that holds the log exporter, where we want to export our logs. We have the log processors defining how often we want to push our logs records to the exporter, and we have the resources. The resources is the identity of our component. The other options to collect logs with OpenTelemetry is to continue using our log library by creating a traditional log file. And we will collect our logs with the help of an agent, such as the OpenTelemetry collector. In OpenTelemetry, the logs record has a specific structure. This structure will be very important to understand, especially when we will start to parse or to enrich the data or extract information from the log stream. We will see later that we will mainly modify or access the attributes, the resources, the body, and the severity. Of course, if you are planning to attach your log to an existent trace context, you will have to manipulate the trace ID, the span ID, and the trace flag. Today, we won't focus on the log bridge support of OpenTelemetry, but on how to collect our logs and parsing those logs with the help of the OpenTelemetry collector. To collect logs, we have plenty of solutions that we could rely on, such as FluentBit, FluentD, PromTail, and now we can also rely on the OpenTelemetry collector. So out of collecting and receiving logs with OpenTelemetry collector, the question would be, are we able to parse, filter the logs with the collector similar to solution like FluentBit? Like explained in the episode explaining how to observe your Kubernetes cluster using OpenTelemetry collector, the collector relies on a configuration file that will be used as a collector pipeline. The community has built several receivers, but also processors helping us to parse and modify our logs. And one exciting news is that the OpenTelemetry community has built a language helping us to transform our logs. It's called OTTL, and that stands for OpenTelemetry Transformation Language. Before describing this new language, let's have a look at the various log receivers available in the collector. To be able to collect logs with the collector, the community has built all the receivers that would be able to receive logs with the various logging protocols. In the logging space, there are several protocols, so TCP or UDP, where a solution will send the logs through TCP or UDP protocol. In this case, the collector will be a UDP TCP endpoint. Then we have syslog. Syslog is a very common protocol used to exchange logs within our environments. Then we have Fluent. So FluentD or FluentBit has their own forward protocol to export logs from their pipeline. Of course, the community has built all the relevant receivers. So we have the TCP receiver, we have the UDP receiver, the Fluent forwarder, and syslogs. Those receivers will configure our collector to listen for incoming log stream. But in most of our cases, we often use traditional files. So the collector has also a FileLog receiver. With this receiver, the collector will read specific files stored on the host where the collector is deployed. In the case of Kubernetes, if we mount the volume /var/log, our collector would be able to read the logs produced by our pods running in the node where our collector is currently running. So that is a reason that we will probably deploy our collector as a daemon set to be able to read all the logs produced in our cluster. So let's focus on the most common scenario, reading file from our cluster using the FileLog receiver. The FileLog receiver has lots of powerful features to read, extract metadata, and more. FileLog receiver comes from the donation of Stanza. So we will see that a lot of things will be related to the way we've been dealing logs in Stanza. So you'll find lots of features that were supported by Stanza. If you want to learn more about Stanza, check the episode related to it. So before describing it, here is the link of the FileLog receiver. The FileLog receiver has several parameters. The most important one is include, that will determine the path that the FileLog receiver will read. Of course, you can use patterns like star to read several files of several folders. This is especially useful for Kubernetes. In this context, I would configure include. So here is an example. Include with var log pods and then /star/star/star.logs. That will read all the logs of all the containers of each pod in this node. One interesting feature is that you can exclude files. So if you don't want to read, let's say, the logs specific for a specific Kubernetes component, you can precise it by using exclude. For example, I can say exclude var log pods and then workload name star, and then it will remove that workload, at least from the FileLog receiver. The FileLog receiver can add in the attributes of the log the file name if the property include_file_name is true. In that case, it will add in the attribute a new attribute called log.file.name with the name of the file. And we can do the same with the path. So here it's going to be include_file_path. And if it's equal to true, it will add an attribute called log.file.path. So with the path of our file. We can also define our own custom attributes or resources using resources and of course attributes. But the most interesting thing is the operators. Operators is clearly the way of parsing, extracting data with the stanza logic. Because the operator is an heritage of stanza, we will find operator for input, parsers, output, and general functions. It means when using this receiver, the operation input and output won't be useful. So here is the documentations of all the operators available. So let's focus on parsers and general functions. So parsers, we have the CSV, the JSON parser, the regex parser, the scope name parser, the syslog, the severity, the time, the trace parser, and the URI parser, and so on and so forth. Each of those parser would have the same property, so parse from and parse to. By default, it will parse from the body, so the log stream, the log message, and send the results in the attributes. Then we have timestamp, defining how to extract the timestamp, severity, how to extract the severity from the log stream, the trace, helping us to extract the trace ID, the span ID, the trace flag from the log stream. Depending on the format of your logs or the information that you would like to extract, you will have to use the correct parser. In the case of Kubernetes, if we look at the file path of a log file, we will find the container name, the pod name, the namespace, the pod ID, and so on. Therefore, we should use a regex parser to be able to extract all the right attributes. For example, here's an example with the regex parser. This example will add the new attributes, namespace, pod name, UID and container name, and restart count. Then we would need to use a common operator to rename or move the metadata to resources. With the common operator, we have add, copy, filter, flatter, and move, and so on and so forth. It's basically the heritage of stanza. Move will move data from one log property to another log property, so resources or attributes. For example, from attributes to resources. In our Kubernetes example, we could do the following operation to add the Kubernetes metadata in the resources. So here we can see that we use an operator type move. We say from attribute container underscore name to, and now we rename our new attribute with resource Kubernetes container.name. And we do the same thing with the namespace. So we precise the attribute namespace and we create the new resource. Even if the log file receiver has operation helping us to parse or create new attributes or resources, the OpenTelemetry community has built an optimized way of extracting the data from our logs, which means we will only use the FileLog receiver to determine what we want to read Then the parsing will be done with the processor, such as the transform, that will rely on the OpenTelemetry transformation language. OpenTelemetry has built a powerful language helping us to transform our logs in an efficient way. OTTL, so OpenTelemetry transformation language, has a grammar structure that helps us to modify or parse our logs based on condition. The OpenTelemetry transformation language will be used in a specific processor and connector. So we have transform, filter, and route that supports the OTTL language. The OTTL language allows us to apply a function on a specific condition. The structure has been inspired by the traditional SQL language. So we have a function, where, and a condition. For example, here, set severity to fail where the body equal request failed. If you want to look at the entire documentation of OTTL, check out the following link. The OTTL has lots of various operations available. Editor that will modify the properties of the data. Then we have converter, providing utilities, transforming the data. So here are the available editors. So we have delete key, delete matching keys, keep keys, limit, truncate all, and so on. All those functions will adjust the content from our OpenTelemetry data. So it's the attributes, the resources, the body, basically all the properties of a log record. Usually those editors can take a function that will extract data from another property to set it as a new attribute. That's the case of set. Lots of those functions are very useful, especially if you want to reduce the cardinality of your data in the case of traces or metrics, or if you want a metrics that has too many attributes, we could use delete key to drop all the unnecessary attributes in that metric. To extract or convert our data, OTTL has several functions. So here are all the functions available with the OTTL. Every time we apply an editor operator, we will be replacing the value of a given property. So resource, attributes, body, and so on. If you need to extract content and then proceed to various operations to replace a value later on, OTTL has the ability to store values into cache. Because OTTL doesn't have any variables, we can use cache to store the transformation of our data before writing it into a specific target property. So let's go back to our initial example where we use the FileLog receiver that will store the path of a log file into the attribute log.file.path. Let's say we want to extract the namespace, the pod name from our log. So we will use the following statement, so merge maps. So we are basically creating a map stored in cache based on the extracted pattern, so with the regex. And you can see here with the regex that we used before is here. We have specific variables, so pod name, container name, restart, and so on. And then we use different statements, so to set the resource attributes, Kubernetes namespace with the value stored, for example, in cache namespace. OTTL introduce also enums that are very useful to test the metric type, the log severity, and more. So we have specific enums for logs. So here are there. It's mainly related to the severity. So if you want to create the severity numbers, you will rely on those enums. So if you want to set the severity number from the body of your logs, you could imagine to do the following statement. So here is an example. So it's set severity text. So we can put the text of the severity based on data stored in the cache. We can set the severity number, and here we are referring to the enum severity number info. And here basically we make a condition on the value of stored in cache equal to info, for example. For metrics, we have also other enums. So here is an example. So we can see that we have all the metrics related to aggregation, so temporality delta or cumulative, and then we have all the types like histograms, gauge, and so on. We have specific enum for span. So here it is, so span kind. To modify our logs, we would use mainly three processors: the transform processor, filter processor, and the Kubernetes attribute processor. We already presented the Kubernetes attribute processor in the episode explaining how to observe your Kubernetes cluster with the help of the OpenTelemetry collector. So let's focus on the other one, so transform and filter. Those two processors rely on OTTL, but you would need to specify for which signals will be targeted by our statements. So let's have a look at filter. Filter would be the processor that will help us to drop records from our pipeline. In filter processor, we need to define which signals would be targeted by our statements. So for example, for metrics, here is it. For metrics, we have filter, metrics, and then we can specify exclude, the regex, and which record attributes we want to keep. Or we can also express it in a different way. So filter, metrics, so the type, metric data type histograms, for example, and isMatch name Kafka star. So as you can see in this example, we can filter to include records or in the opposite, to exclude them. By default, filter will always exclude records that match our conditions. The other important processor is of course transform. Transform will help us to modify our records by enriching or modifying the structure of the log records. Transform processor is a bit similar to filter in the sense where we need to precise the signals impacted by our transformations. So here example, so we have signal underscore statements. So if it's metrics, it's going to be metric underscore statements. If it's log, it's going to be log underscore statements. If it's span, it's going to be span underscore statements. Then we need to specify the scope of our transformation with the help of a context. The context could be log, metric, data point, span, span event, scope, log, or resource. The context resource we only use to transform resources information of the data. With scope, we could change the resource and the attributes. With metrics, on the details of the metrics, so attributes, resource, and the data points. And now we have the data points where we only limit to the value of the metric. And then once we have the context, we basically make a list of statements that we want to apply to our records. So one statement after the other. So if you go back to our example of collecting logs from a Kubernetes cluster, we can use the following transform. So transform log statement. Here the context is obviously log, and then we we can have different operations. So when modifying the logs, we may have specific log pipeline based on the log format, for example. That is where we would use router connector that will determine which pipeline would be used based on specific condition. The routing connector will also be based on OTTL statements. So let's say we want to deal with logs that has different format based on the content of a logs. So connector will be perfect of that. So here is an example. So we have connector routing. Then we define the default pipeline. So we can name that pipeline. Of course, that pipeline needs to exist in our collector pipeline. Then we define the error mode if we ignore and how we manage the errors. And then we have the table with all the statements. So route, where, and then we defined the conditions. One important aspect is that a routing can only have access to resources attributes. You cannot make any condition based on the body, so the message of a log, the log stream. So if you want to make the routing condition based on the content of the logs, you will either use transform to extract content and store it into resources of the logs, or you can also use the FileLog receiver using, like we said before, we use routing and parse the format, and that will create new keys based on the format. Once you have this property, then you can rely on the routing to make condition based on the property that we've just created. So then once we have the routing, of course, you need to define the right pipelines. So here's an example. We have various pipelines. So we have the receiver, the logs pipeline, we will receive a FileLog and exporting to routing. So this is where we're going to make the conditions. And then we have the pipeline for Docker that will input routing and then do the various processor and export to OTLP and so on and so forth for the various format. So if you didn't understand, connector would be used as an exporter and also as a receiver of different pipeline. So the main pipeline, the log one in our example, will export to routing. And then routing will determine which pipeline will be triggered based on the condition. That's it for today's episode related to the OpenTree collector and specifically how to collect logs using the OpenTree collector. First of all, I think what is super exciting is the OpenTelemetry transformation language. There's a lot of great features to extract, to set, to delete keys, to do a lot of various operation into our various signals. So not only logs, but also traces, metrics, and of course logs. So at the end, if you have metrics with a high cardinality and you want to basically reduce the number of keys to reduce the cost of that metric, you can use the OTTL to reduce that the cost of these metrics. And then in the log space, I think it's exciting because at the end with this OTTL language, we can clearly do the similar operation that we've done in the past with FluentD or FluentBit. So at the end, it's pretty the features are quite compatible on one end to the other. One thing maybe, which is because it's a freshly new language provided by the community, I think a few features is still missing to test, because at the end we're doing lots of statements and then testing it requires to look at the output produced from the collector. So building a complex pipeline with the collector is again a bit complex, but I think it should be simplified in the future. A lot of new features will be probably provided by our community. Otherwise, one small tips that I will share is that if you do a lot of processing or a lot of transformation, try to do small ones that are not expensive, because at the end, more statements and more operation that you will do on the collector, specifically with regex, will consume more memory. So keep that in mind. So if you have complex processing data, maybe it would make sense to do very minimal operations, then send it to your backend and do the parsing from there. So Loki, for example, has the parsing features. Dynatrace has the DQL language that will help you parse, or even you can also parse at the source. So lots of those features will be less expensive, I would say, if you do that on the backend side. So try to make it a small operation, because otherwise you will have more challenges to manage the consumptions of your collector. I described recently that 80% of the traffic is from non-subscriber users. So if you enjoyed today's content and you like the format and so on, don't forget to like and also subscribe to the channel. All right. So see you soon for another episode. See you.